Today, we'll explore a remarkable innovation from New York University, NYU, where researchers are creating an AI system that analyzes the language learning process of a child. How can a machine learn to understand the world through the eyes of a child? Imagine an AI not just observing, but truly comprehending the world around it, just as our youngest minds do. This journey isn't about simple observation, it's about unlocking a new way of learning that could revolutionize how machines interact with our world. Traditional AI systems, as we've come to know them, operate on a basis of vast datasets and explicit programming. These systems learn to recognize patterns and understand actions by sifting through structured, meticulously labeled data. However, the team at NYU is flipping the script on this conventional approach. By exposing an AI to 60 hours of video captured from the viewpoints of toddlers, they immerse the machine in an environment teeming with pure, unfiltered experiences of human growth. This is not a traditional learning dataset. It's a vibrant tapestry of life as seen through the most curious and exploratory beings among us, children. So why choose the perspective of a child to teach an AI? The answer lies deep within the foundational theories of cognitive development. The early years of a child's life are marked by rapid cognitive growth, where interactions with the surroundings are paramount. Children don't passively absorb information, they actively engage with their environment, making connections and recognizing patterns in a manner that is both exploratory and self-guided. This phase is critical as it lays the groundwork for complex cognitive functions and learning capabilities. By mirroring this process, NYU's researchers aim to equip an AI with the ability to learn from raw, unstructured data, much like a child learning to navigate the world for the first time. This starkly contrasts the traditional route of feeding AI pre-processed, labeled datasets and offers a more organic, intuitive path to knowledge acquisition. At the core of this innovative approach is the concept of self-supervised learning, moving away from the traditional paradigms of supervised learning, which leans heavily on labeled data, and unsupervised learning, which attempts to unearth hidden patterns without clear outcomes. Self-supervised learning represents a leap towards mimicking human-like learning processes. This method empowers AI to construct its understanding from the data it's exposed to, without needing explicit instructions on what to learn. Instead of being told what to look for, the AI observes and infers, recognizing actions, predicting consequences, and making sense of environmental changes autonomously. This self-directed learning approach is similar to a child learning to speak by listening to conversations, without someone pointing out each word's meaning. Through this lens, AI begins to decode the world, understanding actions not just as isolated events, but as interconnected sequences that unfold within specific contexts. This transition from traditional AI training methods to a more natural, human-like process of learning holds profound implications. It suggests a future where AI can navigate our world with a deeper understanding of human actions and their consequences. Imagine an AI that can predict the outcome of its actions in the same way a child learns that a glass will fall if pushed off a table. By learning from the unstructured, dynamic environment of children's perspectives, AI is stepping closer to a form of cognition that mirrors human understanding, setting the stage for advancements that could redefine our interaction with technology. In embracing the chaos and complexity of real-world learning, NYU's researchers are not only challenging the capabilities of artificial intelligence, but also offering a glimpse into the essence of human cognition. This research does more than push the boundaries of technology. It invites us to reconsider what it means to learn, understand, and interact with the world around us. As we delve further into this journey, we find ourselves not just teaching AI, but learning from it, uncovering insights into the very processes that make us human. Now, let's further explore the cornerstone of NYU's approach, self-supervised learning. Instead of relying on vast labeled datasets or searching for patterns without clear objectives, self-supervised learning allows AI to forge its understanding directly from the data it encounters. This learning style mirrors the way humans gather knowledge from their environment, crafting a learning experience that's more intuitive and in line with natural cognitive processes. It's about the AI observing the world, identifying patterns, actions, and outcomes on its own, much like a child making sense of their surroundings without explicit instructions. This self-reliance in learning enables AI to not just recognize specific actions, but to understand them within the broader context of their occurrence. The magic unfolds as the AI begins to translate the multitude of experiences captured in the children's perspective, videos into actionable knowledge. Through the lens of these videos, the AI is not merely a passive observer, but an active learner, identifying patterns, actions, and the consequences of those actions within the rich tapestry of everyday life. For instance, when it sees a door being opened, it doesn't just register the action of a hand reaching for a doorknob. It understands this action in the context of what leads up to it, what follows, and its implications within that environment. This ability to contextualize and predict outcomes from observed actions is a monumental stride towards creating AI that perceives the world not merely through data points, but through an understanding akin to human cognition. The implications of this research stretch far beyond the academic world, promising to revolutionize the way we think about and interact with AI. This shift towards a more intuitive, human-like method of learning paves the way for AI systems that are not only more adaptable, but also more in tune with the nuances of human environments. In sectors like robotics, healthcare, and education, the potential is vast. Robots could be trained to understand and navigate human environments more naturally, interpreting cues and interactions as a child does. This could lead to robots that are more intuitive companions, or assistants in homes and workplaces capable of performing tasks with a better understanding of human context and needs. In healthcare, this AI learning approach could lead to systems that offer more personalized care. For example, AI could interpret patient behaviors or expressions in a more nuanced manner, aiding in diagnostics or tailored patient interactions, improving patient outcomes and experiences. The education sector could see AI systems that adapt learning materials to the unique styles and paces of individual learners. By understanding how children acquire language and concepts from their surroundings, educational AI can be designed to facilitate more natural and effective learning experiences, catering to the diverse needs of students. But the journey doesn't end here. The research undertaken by NYU's team is not just a testament of technological advancement, it's a beacon for the future of AI, illuminating the path towards systems that understand and interact with the world in a way that's truly reflective of human cognition. It marks a transition from machines that perform tasks based on predefined algorithms to ones that can interpret, predict, and engage with their environment in a dynamic, context-aware manner. This leap towards more naturalistic AI learning methods not only enhances the capabilities of machines, but also opens new avenues for collaboration between humans and AI, fostering a future where technology understands us just as well as we understand it. The journey through NYU's pioneering research reveals a future where AI transcends its traditional boundaries, offering a glimpse into a world where machines learn from the chaos and complexity of human life. This breakthrough is not just about making AI smarter, it's about redefining the essence of machine learning, nurturing a breed of AI that's more intuitive, adaptable, and ultimately more human. As we stand on the brink of this new era, the potential for transformative change in how we live, work, and interact with the machines around us is immense, promising to reshape our world in ways we're just beginning to imagine. As we wrap up our exploration into New York University's groundbreaking AI research, we've seen how blending the learning processes of children with artificial intelligence opens up thrilling new possibilities and challenges us to think deeply about the ethical implications. This venture not only pushes the envelope in technology, but also invites us to imagine a future where AI enhances and enriches our human experience in profound ways. Now, it's your turn to weigh in. How do you feel about using perspectives of children as a model for teaching AI? Does this innovation approach to learning spark your interest or raise concerns for you? We're eager to hear your thoughts and engage in a lively discussion in the comments section below. If you found this journey through the cutting edge of AI as fascinating as we did, don't forget to hit the subscribe button.